Hello and welcome to my YouTube channel. This is Jonathan Goldfish. Be sure to like, share and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back to this YouTube channel. This is Jonathan Goldfish. Okay, so for this video today, we are finally entering the final chapter among the pure mathematics one, which is the chapter 8 integration. Okay, in fact, I'm in the UM physically, okay, because I have to pursue my undergraduate studies, alright? So this video is talking about the integrations, alright? And you have to learn its fundamentals. Alright, what to know about the integration is, it is actually the antiderivative under the branch of the calculus, alright, as the previous chapter that we have learned that about the differentiations. Okay, and it also has another definitions of the area under the graph. Okay, by sum up the areas of the strips. Alright, as each width of the strip approaches 0. Okay, this is also related to the limits. Alright, so as we know that integration is antiderivative or the reverse process of the differentiation, here is the map, okay, for your understandings. Alright, so the problem over here. What is the long S means? What does the long S mean? Okay, long S in the integration is very crucial because long S, this symbol is a sigma in the uppercase. It refers to continuous summations. Okay, it is actually the continuous summations as the limits of the change of the x is approaching 0. Okay, for this we call it as the Riemann-Sum theorem to be discussed later. Okay, so for the dx means the respect to the small change of the x. Okay, the small change is very small and even it's negligible. Alright, so let's interpret over here. Given that the dy dx is equal to the f prime x, okay, so we can rearrange again into this integral form. So to get back the original functions, it is the long S integral of the f prime x dx, where this function to be integrated, we call it as integrand. Long S, of course, we have I've explained over here, it refers to continuous summations. Dx is the small change of x. Okay, so for the calculus students, please get familiarized with it. Alright? Okay, that is just a basic introductions about the integration. Now, this is the importance for A-level students, especially math students. Alright? So first, generally all the results come from the differentiation. Indeed, because differentiation is the reverse process of integration. Take a look. Let's take a look at the first rule. In the first rule, constant function. So how to integrate a constant is actually you add the x beside, don't forget the plus c. Second, polynomial functions. Okay, when you are dealing with the integral of the x power n, because it's the polynomial functions, so it's n plus 1 divided its degree when it is plus 1. And don't forget the plus c. Okay, I know many of you are curious why there's a plus c in the results of the integral. We will explain this later. Okay, so this rule is valid except for the n is equal to -1. Why? Because if you apply -1, you are integrating the reciprocal functions, which is the 1 over x. Okay, which is unintegratable. Just only to use the polynomial function integral rule over here. So for this is the A2 syllabus. you will be learn this later. Okay? So yeah, to let this rule become valid and applicable, your n must be in real numbers, except for n is equal to -1. Okay, what about the coefficient beside the function? Okay, to integrate this kind of the functions, this rule explains that the a must be taken outside. So yeah, it is well related to the limits. Alright? Okay, sum of difference or the arithmetic integration. So no matter what kind of sign over here, okay, eventually the integrals is separable. I mean, both functions are separable, right? Okay, what about the reverse chain rule? So there's an inside function for your syllabus. The inside function will be linear function only. Okay, if it is the second degree or even higher, even greater degree, and I don't think it's possible. All right, so please rest assured that in your AS syllabus, you will be only learn the inside function, the integration of the reverse chain rule. The inside function is only linear at most. All right. So this rule is only applicable when the n is all when the n subsets to all real numbers except the n is equal to -1. Why? Because if you apply n equals to -1, its integral is actually the logarithmic functions. So yeah, take note about this. Okay, it's important for you all. All right, to integrate the inside functions, let this become the u. So you will have the integral of the un. So now un plus the +1 on the degree divided by the number of degree that you have added 1. And don't forget the a. Why? Because we are taking the derivative of inside. But it's actually not lah. This is actually the reverse chain rule only. Okay? So anyway, this rule applies that this integrate this reverse inside functions with the power of n plus 1 divided by n plus 1 in the bracket it like this and times a in the denominator, just like that. And of course with the plus c. Alright, so now is the time to explain why plus c must be exist in the indefinite integrals. Why there's indefinite integrals? Because there are no limits on the top and bottom right corner of the long S sign. So why? Why plus c? Okay, let's use the examples. For instance, there is a x squared. Okay, try to integrate. You will integrate the function as x cubed divided by 3, right? It can be, so for the constant, it can be +5, +6, and even +7. Okay, so plus c can be only determined, okay, for the exact value of the c if the boundaries are given. For example, x equals to 2, y equals to 8, substitute the boundaries inside, or we can say that this coordinate meets the function to get the plus c. Okay, because the plus c in the graph lah, okay, it graphically represents inside as the translation, right? So it can be +5, +6, +7, provided that the c is the real numbers. Okay, so this is why for the indefinite integrals, without the limits given, plus c must be added. Okay, please bear in mind. All right. Lastly, for the prompt, during you are applying the rules of integration, this is the prompt. So the integral of the multiplication of two functions is not equal to the integral of the first function times the integral of the second functions. Okay? So please do not make this kind of basic careless mistake. and even the quotient integral as well, which is the fx divided by gx, okay, as the integrand of the integral is not equal to the integral of the fx divided by integral of the gx. Okay, so these are the common mistakes that part of the students make. Okay, so anyway, in summary, you have to learn 5 of these rules of integrations in AS syllabus. All right. So yeah, let's proceed to the next segment, shall we? All right. Here comes the second subtopic among this chapter, which is the problem solving in integration. Okay. So to deal with the problems that involving the conversion from the gradient function to the actual equation or original equation of the curve, okay, integration is necessary to be performed and occurred. Okay, so this is the best stacker questions related to the indefinite integrals. Okay, so when I say the term of the indefinite integral means what? After the integration, we have to put the plus c. Okay, what's the reason? As I have told you before. Alright, so in your AS syllabus, okay, you are going to integrate only a polynomial function. In other words, okay, the integration only involves polynomial functions in the AS syllabus, so no worries. Okay, so here are the steps to tackle the questions. So first, get the gradient function in terms of x by right. That is your integrand to be integrated. Okay, or we can say that it's a gradient of the tangent. After you integrate it, respect to the x, you will get the result, and don't forget the plus c. Okay, so how to integrate your polynomial functions? Please refer to the rules of integration above. All right, and some, yeah, like this. Okay, anyways, plus c cannot be ignored. All right. Okay, second, substitute the given boundaries in the equation to find the value of the c. Like the point, there's a keyword of, for example, the point of the PQ that lies in the original equation, that is the one of the solution or the intersection point inside the curve. Alright? Substitute the points or the boundaries. This is called boundaries inside the equation of the curve to get the values of c. So by right, the value of c must be in real numbers. And finally, rewrite the full equation of the curve with the values of the constant that you found. Alright? So yeah, each step is crucial for awarding the marks beneficiary for your own sake. Alright? Make sure to not to do any careless mistake. For sure. Alright? So in summary, integrate, substitute, rewrite. That's all. Okay? This is to teach you how to deal with the indefinite integrals. Alright? Okay. So this is the second subtopic. Let's move on to the third subtopic, which is the definite integrals. Okay. So what is definite integral? Please refer to the term definite. Means what? There is a limits. Alright? So this is an integral that has limits to be evaluated. So which means that its value must be in the real numbers. Okay? And it is used to calculate the area under the curve and the volume of the revolution, as I have told you earlier. Okay? Integration is actually the summation, continuous summation of the area of the strips. Okay? So, for this method, we can prove by using the Riemann sum to be explained later. Okay? So for the function for the function fx is continuous at every point in the intervals of the limits. Okay? The integration the integration of the fx from a to b, okay, we say from a to b, so a to b are the limits, all right, to restrict this for certain boundaries to get the area under the curve. Okay, I hope that you remember the fact about definite integral is area under the curve. All right, and many of you ask why there's no plus c in the definite integrals. Here is the reason. It's because of the plus c is independent of x. But this, I know that explaining this statement is obviously not enough for you to understand. So here is the explicit explanation for your understanding. So after you have integrated fx, right? So you try to add plus c, right? And now, eventually, each limit has to be substitute inside for the first and the second. Why? Because the big part of the area minus the smaller part. Okay? So this is like you are determining the area of the triangle, right? So how to get it? It's the area of the entire whole diagram, trapezium, minus the rectangle. So what I want to eliminate is the rectangle. So the portion of the area to be eliminated is actually the a, which is the lower limits after we have integrated over here. Okay? So do it in the same way. What you can see over here, c plus doesn't get affected because it's independent from x1. Okay? And after you open the bracket, what you can see over here, the plus c and another plus c can be cancelled out to each other. Okay? So that's why when you evaluate the definite integral, c is not required to be added inside. Alright? But remember that fx is the antiderivative of fx that you have integrated. B is the upper limit and a is the lower limit. The log si refers to continuous summations, okay, as you know. And dx is the small change of the x for each interval. Okay? But here are the warnings. Limits of b and a must be written at top of the bottom of the log si, just on the right hand side. Okay? Please bear in mind. Alright? Bear in mind and write it properly when you solve the definite integrals. Okay? So here are the properties of the definite integrals, which are commonly seen. First, same limits. So assume that fx is the continuous. After you integrate it, you substitute the a minus the fa, you will get 0 because of the same limits. Why? Here is the visualization. So let's say this is the bigger fa, right? I want to minus away fa. So which means what? You take away all diagram. So means what? What area you get? Nothing. So it's 0. Okay? Okay, second, reversing limits. So the integration of this from b to a is equal to the negative BOA by swapping the positions of between the two limits. Okay? Third, constant multiple of the definite integrals is actually you just taken out. Okay? That's all. 4. The arithmetics sum or difference for the definite integrals is always distributed evenly. Alright? For the fx and gx are both continuous functions. Okay. Fifth, interval splitting. Okay? Where the fx is the continuous, alright? From a to b. Alright? So this integral can be splitted into integral fx from a to c plus from c to b, provided that c must be in between a and b. So here is the, let's say there's a curve of the fx. I want to find, I want to split the integrals with the terms of c. So c must be in between the intervals of a to b. So let's label the c at any way round, which is over here. Okay? So c must be in between a and b in order for this interval splitting to be valid. Okay? So let's move on to the next subtopic, the area of the region bounded by a curve, the x-axis and the lines. Okay, as I have mentioned earlier, area under the curve is the integration of the curve equation for the given limits, or the limits constraint, or the area under the curve with the limits provided required only. So this is how you evaluate the area under the curve from the Cartesian diagram or the Cartesian graph. Okay? Whereas for the bounded by the y-axis, just now it's the bounded by the x-axis. Now it's y-axis. What if this situation appears? Okay? So you must take the limits from a to b that crosses through the y-axis. So what is it? It's actually the area of this region is actually the integrals of the x in terms of y respect to the y from a to b, where the a and b must be y values. Alright? Or the y coordinate. So here's the prompt that you should rearrange the equation of y equals to fx into x in terms of the y. How to do so? You just take the inverse function. Okay? Just take the inverse function to get the functions and substitute inside. Alright? Just that for the boundary limits, you must use your own mathematical fundamentals. Okay? So finally, here comes the sum. The proof of the area of the region is actually the integrations. Alright? By using the Riemann sum theorem. So considering about the area of the rectangles that bounded within the curve, so I know each of you say that it's not accurate at all. Yeah, the errors is too much. So what should we do right now? Over here, okay, is to carefully and gently add more strips within, as long the upper end of the rectangle strip is covering the curve completely. Yeah, the arc of the curve completely, without any presence of the certain areas of the rectangle above the arc of the curve. Alright, so you slowly added the rectangles with about the same width, which is the delta x. Alright, you add up as much as you can. Of course, I'm talking nonsense. It's because of the more the strip you added, okay, the width of the strip, each strip, which is the delta x, is approaching 0. So which means that it's not measurable by your own. Okay? So here's the summary that the more the area of strips added under the curve, the more accurate to the area under the curve for the given interval. Alright? So see over here. So as the width of each strip or the delta x is approaching 0, the area under the curve approaches the exact integration of the fx from a to b. Okay? Hence, area under the curve is equal to the summations of the fx times the delta x, change of the x from a to b, and then this summation is taken by the limits as the delta x goes to 0 or approaches 0 to get the integrations of the fx from a to b. So therefore, proven. Okay? Now let's move on to the another scenario, which is the negative area. So in the Cartesian plane, there are 4 quadrants, right? Sorry, my bad. Okay? This is positive region, or the first quadrant, which is above the x-axis, and the region which is on the right of the y-axis. So this region, to be said, is taken as positive. What about the negative? It's under the x-axis, of course, because it's y negative and the y positive. Makes sense, right? So since the area is always positive lah, the area of the A, or the sum of the two areas, for the first, you must calculate the areas of both separately. So first you determine the positive region first, that's easy. And second, you can integrate, you can find the area of this negative region. Just that after you should get a negative value, you must take modulus, because area is always positive one. Okay? Okay, another scenario is, what if the curve bounded about the y-axis with the given y intersections, or the y-intercept, right? So of course, you must arrange the equation y equals to fx into x equals to f inverse y. Alright? Or the x in terms of the y, in other words. So since the area is always positive, therefore, what it takes into account is the positive region, which is on the right of the y-axis. This is positive region. Otherwise, on the left hand side, it is taken as negative. So to get the area of the both regions, calculate the positive region first. Easy part, to save your time. And then integrate the negative regions. Alright? Of course, you will get the negative value. So you have to modulus the negative value to make it positive, and then to be summed up with the positive region that you have calculated. Okay, here's the summary. Please go through by yourself. Alright? Next, area bounded by the two curves, curve and the line. So if this is the case, I want to find the area of this region only, without finding the regions on below. Oh, I mean, like, I want to get rid away this region. So how? With the two curves one. Okay? So to get the area of the shaded region over here, where is the upper arc? This line. So what is the function of this line? Fx. Okay? Sorry guys, I think I made a mistake. My bad. So this should be fx, because the curve of the fx is on the above. I think I'm not gonna change. So instead, let's swap it. Let the let this above gx and fx for the lower one. Okay, so here's some corrections, please swap it. Alright, gx is in on above and fx is in below. Alright, so the area of shaded region is to get the integration of the upper is actually the area of this region first minus the area of the area under the curve for the lower region, which is this region. Let me change the color. Yeah, this region. So in summary, to get the area of the region, find the area of the upper region entire first, the bigger one, the largest one, minus the smaller region. Okay? So hopefully my sketchings you can understand. Alright? So of course this is very essential for your understandings, and of course although this is the last chapter, but you still have to practice, because practice makes perfect. Alright? So yeah, okay. So during this halfway segment stops, I need you to digest what is area under the curve about and how it relates to the integration. So please go through by yourself and digest. After the digestions, let's continue the next subtopic. Okay guys, due to the video length, I have to stop here for the part 1. Okay? So in the next video, we are going to talk about the warnings of revolution and finally the improper integrals before we end this chapter and the journey of the pure mathematics 1. Okay? So make sure to hit the subscribe button with the bell, hit the like and share this video if you find this video helpful. Okay? So yeah, thanks for watching. I'll see you in the next video, part 2. So long. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.